We are now working on systems of equations, and we know a system of equations exists anytime we have a set of two or more equations in the same variable. And when we solve a system of equations, we're trying to find a solution that works in all of the equations simultaneously. So here you can see we have a system of two linear equations, the red one and the blue one. And I'm telling you right now the solution to this system of equations is the ordered pair 2, 3. And it is a solution because it's the only ordered pair that will work in both of those at the same time. And I can prove that to you by just substituting in those values into both equations, and you'll see it will be true for both. So for the first one, I will substitute 3 for y. Let's keep our colors the same. Substitute 3 for y. And 2 for x. And because the x is negative, it's going to become negative 2. And negative 2 plus 5 would give me 3. So because I have the same value on both sides of the equation, it works. Let's try it in the blue equation. I will substitute 3 for y and 2 for x. So 2x becomes 2 times 2. So I end up with 3 is equal to 4 minus 1. And again, I end up with a value of 3 on both sides. That ordered pair worked in both equations, and it happens to be the only ordered pair that will work in both of those at the same time. I can prove that to you, and we'll do that in the next step. And this is also how we could possibly solve this system of equations. What if we didn't know 2, 3 was the solution? We want to solve it ourselves. One way to do that is by graphing both of the equations together on the same coordinate plane. So let's graph the red equation. Because it's in slope-intercept form, it's pretty straightforward to graph. Right? I start with my initial value. I'm going to start with my y-intercept, which for the red equation is 5. So I'll go to the y-axis, put it out at 5. And then remember, the slope of this one is actually negative 1. And if I think of that as a fraction, negative 1 over 1, I can now plot some other ordered pairs. Right? I'm going to go down 1, right 1, down 1, right 1, because I have a slope of negative 1. So now I can draw a line through that set of ordered pairs. So I've just graphed the red equation. Right, now let's do the same with the blue. Again, it's in slope-intercept form. So I can start at my y-intercept, which is negative 1. This one has a slope of 2, which if I think of that as a fraction, is 2 over 1. So that means I'm going to go up 2, right 1, up 2, right 1, up 2, right 1. And again, I can draw my line through that set of points. And let's keep our colors the same. So now I've graphed the blue equation. And I can see that my red line and my blue line only intersect in one spot. And that one spot that they happen to intersect occurs right here at the ordered pair 2, 3. So there's the solution to this system of equations, because it's the one ordered pair that works in both of them simultaneously.